First question is given that xi for each I equal to 1, 2, 3, 4, or to write this as x1 will be greater than 1, x2 will be greater than 2, x3 will be greater than 3, and x4 will be greater than 4. Since we have xi, the number of integer solutions, right? So that means x1, x2, x3, and x4 are all integers. Therefore, we can write this as x1 is to be greater than equal to 2, or x2 is greater than equal to 3, x4 3 is greater than equal to 4, or x4 is greater than equal to 5. So our question says, given this condition, you have to find the number of integer solution of this equation here. So one thing we can, so I know that x1 has to be at least 2 or 3 or 4. So one solution we can get is, but x1 is 30. No, the other cannot be 0, right? So this is the wrong solution. One thing we can have that x4 is 5, x3 is 4, x2 is 3, and 18, 18. So this is one solution. So like this, you have to find all the number of solutions. So one thing we can take is, we know x1 is greater than equal to 2. So we can take x1 equal to x1 prime plus 2. Since x1 is greater than equal to 2, x1 prime is greater than equal to 0. This when x1 is 0, the minimum value of x1 has to be 2. Since we can define that x1 has to be greater than 0, that is x1 is the natural number plus 0. So then x1 prime can take 0 to all the natural numbers. Like that, we define x2, where x1 prime, x2 prime, x3 prime, x4 prime are all positive integers. Therefore, x1 prime, x2 prime, x3 prime, x4 prime are all greater than equal to 0. Now, we use balls and bars method. That is, we have how many number of indistinct balls do we have? For that, we put x1 prime plus 2 value in x1, x2 prime plus 3 value in x2, and we modify this into x1 prime plus 2 plus x2 prime plus 3 plus x3 prime plus 4 plus x4 prime plus 5 equal to 30. Or x1 prime plus x2 prime plus 4 prime equal to, therefore by using balls and bars method, number of solution is 16 plus 16 plus 4 minus 1, c 4 minus 1. That is 19c3. This is our answer for the first question. The second question, we have x1 has to be greater than 1 to less than equal to 7, and all the x's greater than equal to 0. That means x2 is greater than equal to 0, x3 is greater than equal to 0, x4 is greater than equal to 0. Only x1 is smaller greater than equal to 2 and smaller than equal to 7. So one thing we can do is use inclusion and exclusion. We define x1 as x1 prime, like the first question, plus 2. And then x1 is greater than equal to 0. And we simplify the equation. X2 plus x3 plus 4 equal to 30. 1 prime plus x2 plus 3 plus x4 equal to 28. Therefore, number of solution to this equation, where x1 prime is, where x1 greater than equal to 2 is 28 plus 4 minus 1, 2 is 4 minus 1 equal to 31, 3. And then now we find the solution to this same equation where x1 is greater than 7. That implies x1 is greater than equal to 8. Or we define a new x1 plus 8 such that whenever x12 is 0, this x1 is minimum 8. And please notice this is not square, this is just a way of noting this number. The number of solution to 1 plus x2 plus 3 plus x4 equal to 22 is 22 plus 4 minus 1, c4 minus 1 equal to 25, c3. Therefore, by inclusion-exclusion principle, our required solution equal to number of ways all than x1 is all greater than 2, 31, c3. minus all the solutions where x1 is greater than or equal to 8. 25C3. This is our desired answer. Therefore, the last question is given like this. X1 is greater than equal to minus 5, x2 is greater than equal to minus 1, x3 is greater than equal to 1, or we can imply that x3 is greater than equal to 2, and x4 is greater than equal to 2. Then, like the last questions, we can assume x1 prime such that whenever x1 prime is greater than equal to 0, x1 is greater than equal to minus 5. x2 will be x2 0, x3 will be 0, x4 will be, then the equation 1 plus x2 plus x3 x4 simplifies to 1 prime plus x2 prime plus 3 prime plus x4 prime equal to this goes to 32. Therefore, number of solution to this equation is 32 plus 4 minus 1 c 4 minus 1. That is 35 c3. This is our desired answer.